In this doodlecast, I'm going to walk through all of the process for testing using an independent t-test. And as you can see, we have our research scenario here stating that they're looking for is the number of alcoholic drinks consumed per week greater for fraternity members than people not members of a fraternity. And it shows that they're wanting to test using alpha 0.05. So we're going to go through all the steps of testing using the independent t-test. So let's data. So here's what we have. Clearly we have 1, 2, 3, 4, 5 people in the fraternity group, and we have 5 people in the non-fraternity group. So this is something you want to make note of immediately, is these types of things. So N for group 1 equals 5, and N for group 2 equals 5. So let's start out with just step 1. Before we start any calculations, we're going to start with step 1, which is, as you know, hypotheses. So we're going to state those hypotheses. So if you remember, the question was, do fraternity members drink more alcohol per week than non-fraternity members? So our null is that fraternity members do not drink significantly more alcohol than non-fraternity members. I'm just going to put non-frat members. So that null again is that do not statement, and we have our more, which is suggesting increase or one tell. Our alternative, we're just going to state, I'm going to abbreviate frat members will drink significantly more alcohol than non-frat. So immediately we set ourselves up. We know that because we have these statements of direction, the more, that it's one tell, and because we're looking for an increase, our critical value is going to be one telled, and it's going to be positive. So let's go to step 2. Is setting our criteria. That's where we locate our critical value. If you remember, we had n of 1 equals 5, and n of 2 equals 5. That's our sample sizes. So that means if we combine these, we're going to have degrees of freedom for group 1 equals 4. Degrees of freedom for group 2 equals 4. If we combine those for our t-crit, we're going to have a degrees of freedom equals 8. So that's what we're going to use to find our critical value. Now, if you remember, we'll go back to this data set. We're going to use alpha 0.05. So be sure that when you look in your t-table, that t-distribution table, at the back of your textbook, that you're looking in the column for 0.05 in one tell, and you're going to look up degrees of freedom of 8. And if you'll notice, you get 1.860. And that's going to remain positive because we are looking for an increase. So this is one tell very specifically for that t critical value. So when we are looking for significance, we're just looking in this end. So we have 1.86. Anything that falls above that is significant. So this is where we start calculating our test statistic. So as you can see, here is our t obtained equation, the mean 1 minus mean 2 divided by the estimated standard error of the mean difference. So let's just start getting our basic calculations. So this is what I do. I have my data set here, and we're just going to start doing our basic calculations. So we know sample size is 5. Now I'm going to start getting the data for each of these. If you calculate, you should get a sum of x for group 1 of 20. Then you should get also a sum of x for group 2, which equals 10. For group 1, our mean equals 4, because 20 divided by 5 is 4. For group 2, our mean equals 2, because 10 divided by 5 is 2. Then we also need to get our sum of x for group 1, or sum of x squared for group 1, I'm sorry. That means squaring each individual score and then adding. If we get that, that's 90. So that's 6 squared plus 3 squared plus 2 squared plus 4 squared plus 5 squared. Then we're going to do the same thing for group 2. And you should be getting 10. So you have 0 squared plus 2 squared plus 3 squared plus 4 squared. And that doesn't sound right. So let me, oops, sorry, 30. Ah, see, I made an error. I dropped my eyes down. Caught me in an error. That's okay. 30. See, it didn't make sense for the data, so I immediately could catch that. So sometimes it's good just to sit back and kind of go, does that make sense to be that low? And in that case, it didn't. So we also need to get our sums of squares for both these groups. So remember, sums of square is going to be that sum of x squared. So we're going to do for group 1, 90 minus 20 squared divided by 5 is what that is. So our sums of square for group 1 is 10. Our sums of square for group 2 equals 10. So that's nice and easy right there. We have equal sums of squares. So at this point, because we have our sums of square, we can test our homogeneity of variance. And if you remember, homogeneity of variance is the larger variance divided by the smaller variance. But in this case, we can actually, because we have equal sample sizes, we can use sums of square large over sums of square small, which we don't have a larger or smaller because we have 10 for both over 10, which equals 1. So we know HOV was met because 1 is less than 2. So we know HOV was met. So we can continue on with our calculations. So take note of our sums of squares. Sums of square for group 1 is 10, and sums of square for group 2 is 10. And we have sample size of 5 in each. So we're going to move to the next slide so we can have more room. So I'm going to write those down real quick. Sums of square for group 1 is 10. Sums of square for group 2 is 10. We have a sample size for group 1 of 5 and a sample size for group 2 of 5. So the first thing we need to do is get our pooled variance. So our pooled variance is sums of square for group 1 plus sums of square for group 2 divided by degrees of freedom for group 1 plus degrees of freedom for group 2. So we end up with 10 plus 10 all divided by 4 plus 4, which ends up being 2.5. So, I'm sorry that's so sloppy. Now we're going to plug that 2.5 into our estimated standard error equation. If you remember, that is a subtraction sign, which is the pooled variance divided by sample size 1 plus pooled variance divided by sample size 2, all under the square root. Now when you do this, be very careful that you're doing things in the right order. So for me, it's 2.5 divided by 5 plus 2.5 divided by 5, all under the square root. Now our order of operations is going to have us do those divisions first, then the additions after, before we take the square root of the entire fraction, or the entire equation there. So basically is what I do in my calculator is do 2.5 divided by 5, so you should get 0.5, and I go times 2, which is 1, and then I take the square root of that answer, which we know is 1. So now we have everything we need to calculate our t obtained. So if you remember, t obtained equals m1 minus m2 over estimated standard error of the mean difference. Okay? So let's look back at what our means were. So we had a mean for group 1 of 4 and a mean for group 2 of 2. So 4 minus 2, group 1 is 4, and it's important you get those in the right order. And then we're going to plug our estimated standard error into that denominator. 1. So when you calculate your t obtained, you should get 2 or 2.00 officially. So we have our t obtained now of 2. We're not done. If you remember, we have more as far as calculations. We need to calculate an effect size, and we also need to calculate a confidence interval. We're going to go to effect size. And I'm going to use Cohen's d for our effect size for this one. So d equals mean 1 minus mean 2 divided by the square root of our pooled variance. Okay? So we know that our Cohen's d in the numerator, the mean 1 was 4, mean 2 was 2. We can tell that this last slide, right? 4 minus 2, the numerator. And then we need to use our pooled variance. So if you remember here, I'm going to kind of circle it, here's our pooled variance, if you remember. So we know pooled variance is 2.5 just by looking at that, pooled variance. I'm going to plug in our pooled variance here. Again, 2.5, but we need to have that square root over that. 4 minus 2 divided by the square root of 2.5. So we get 2.5, 1.265. So now we have our Cohen's d, and I could just round that. So d equals 1.27 for our Cohen's d. Now we have an effect size. So now I'm going to move forward, and I'm going to go ahead and calculate our confidence interval. So the next, let's do this as, I'm going to erase this because we're still working on step 3. Because we still need to include our confidence interval. what we need. And we're going to put here, actually I'm going to put continued. So we're still working. So I'm going to state we need to get our confidence interval, and we need a 95% confidence interval, because if you remember, our alpha level was 0.05. So we know that we're going to have to use a 95% confidence interval. If you remember, for independent t, it's mean 1 minus mean 2, plus a minus because it's a two-tailed. That's your t crit. And that shouldn't have a little mark there, but our t crit times our estimated standard error of the mean difference. Okay, so let's look back. If you remember, our mean 1 was 4, our mean 2 is 2, and now that I'm going to keep those together, and we're going to do plus or minus because we're going to have that critical value. Now we're not going to use the critical value 1.86 because that was for one tell. We need to look up our critical value for two tell. If we go back all the way, if you remember, we have 5 in each group. So we're going to have a degrees of freedom of 8, and we're going to look up 0.05, two tell, and you should be getting 2.306. So 2.306 for our t crit. And then we need to plug in our estimated standard error of the mean difference. And that, remember, that is the denominator of the t-test. So if we look back here at this slide, we know it was 1. So here's our estimated standard error of the mean difference. Here's what we ended up with, 1. So now we can actually plug that in. Makes our life easy because it is 1. We can plug in 1 right here, and then we can start our calculations. So if we calculate these out, I'm going to get a lower boundary of negative 0.306. Then the upper, after calculating, I'm getting 4.306. So lower and upper boundary are both, can be both rounded to 2 decimals. So we're going to have negative 0.31 and positive 4.31 is what we're going to have. Now that crosses over 0, so that's problematic. It's pretty close to 0, but it's still, it tells us basically that we probably need to increase our sample size, tighten things up so that we're not crossing over that 0, because that's a problem, because that's kind of saying that scores go up and down, below or to no change to some change. So there's too much variance there. But let's go ahead, and it doesn't matter because it still needs to be stated in APA format, depending upon where your T obtained fell with your T crit. So let's go a new slide, and we're going to deal with step 4. And this is our APA statement. So if you recall, we had our critical value at 1.86. So anything over here is significant. If we go back to our T obtained, we got a T obtained of 2, if you recall. So let's find that would fall. Well, 2 would fall over here somewhere, right? 0.00. So that's significant. So now we can go ahead and state everything that we just found. So I'm going to make my statement first. So we did see that fraternity members did drink significantly more alcohol than non-fraternity members. Right? As, and we're going to do our T, and then here's where we're going to put our degrees of freedom. If you remember, our degrees of freedom was 8 because we had 5 in each group. 8 equals our t-test, our t-obtained is 2. So we know if it's significant. P is less than alpha, which was set at 0.05, 1 tell, with our Cohen's D. Let's look back. I don't remember what that was. So let's look back. D was 1.27. So 1.27, and I'll run out of room over there. 95% CI for confidence interval. And if you remember, we had negative 0.31 and positive 4.31. So negative 0.31 and 4.31. Period. So that is everything. That's everything that you need to include in your results. And again, I can't state it enough, it has to be in APA. Has to. And this is the order that it falls in. Your T, degrees of freedom, T obtained, P related to alpha, whether alpha was 1-telled or 2-telled, an effect size, and a confidence interval. So that wraps up calculating that independent t-test. Now you can work on your hybrid activity.